Welcome to Mathematics 1100, August 2023 for the December 2022 intake, test 2. Now, to have things underway, let us move straight to question number 1a, which reads, given that f of x is given to 2x squared plus 12x minus 7, and the first part of the question says, determine the nature of the roots of f of x. Now, when we are trying to determine the nature of the root of f of x, we need to make sure that we list down the data according to our question. A is 2, B is 12, and C is negative 7. Now, we are going to use a formula to determine the nature of the roots of our equation by saying discriminant is given by the formula b squared minus 4ac. Now, according to our data, our b is 12, so we're going to say 12 squared. Our a is 2, and our c is negative 7. So 12 squared is 144, and negative 4 multiplied by 2 multiplied by 7, we're going to get positive 56. So 144 plus 56, the answer would be a 200. Now, this is the way in which we're supposed to conclude. We're going to say, since discriminant is greater than 0, then the nature of the roots of f of x are two distinct real roots. Just like that. Then we're going to move on and look at the second part of our question, which says, solve f of x is equal to 0 by completing the square. Now, in this case, we know to say, if f of x is given to 0, we are just going to replace that one with a 0, is equal to 2x squared plus 12x is equal to 7. So this can be rewritten as the first part and equals to 0, just like it is shown in the second part. Now, the first step is we need to make sure that the a part is equal to 1. So we're going to divide across with 2's. So 2 into 2, it is 1. So we're going to go to write it as x squared. And then 2 into 12, it's 6x. And then 7 over 2, I've just left it in a fraction form as 7 over 2. So this part is going to go on the other side. The c part is supposed to go on the other side. That is step number 2. So which we have it in this manner. Then we make sure that we find half of what is our b. So half of 6 is 3. So we're going to say 3 squared. And then we add it to both sides. So we have our 3 squared here and our 3 squared there. Then we continue. We say, fine. If we try to factorize this part here, we're going to have x plus 3 raised to power 2, which is equal to 7 over 2 here, plus 3 squared, which is a 9. We continue. We're going to add 7 over 2 plus 9, which is going to give us 25 over 2. Then we'll divide, actually we'll multiply, or we'll equate both sides with of course with the root, so that we get rid of the power. So having done that, the power will go, this power there, and the root. And then the root of 25 over 2, when you punch in a calculator, it's going to give you plus or negative 3.5355 to 4 decimal places. So this positive 3 is going to go on the other side, and we're going to have negative 3. Then we calculate, we say positive, we pick one part. Of course, one part is a positive and the other part is a negative. So our positive is this one and our negative is this one, and then this is our negative 3 and our negative 3. Punching that in the calculator, we're going to get 0.5355 or negative 6.5355. When we round it off to 2 decimal places, this is what we're going to get. We're going to get 0.54 and negative 6.54. That's the second part of the question. The third part of the question rather says, or it demands us to sketch the graph of the solution of what we have here, of our equation. So having already the first two answers, when y is equal to 0, we have two values there. The answer for x can either be 0.54 according to this part, or negative 6.54 according to what we found, but we need to find the turning point. So this is our main focus in this matter now. So what is our midpoint? So for us to find the turning point, we need to find the midpoint of our x values. Since we have 0.54, we add it to negative 6.54 and then divide by 2, because when we're trying to find the midpoint of any value, you add the two values, then you divide by 2. So when you punch in these values on a calculator, you're going to get negative 6, and then we divide by 2, which is going to give us negative 3. So this is our x value here. This is our x value. But the question also demands us to know, what about in the y-axis? Where is it going to turn? So we need to find the turning point in the y-axis. So we move on and then just plug in wherever there's x, we're going to plug in negative 3, because we know x is negative 3. So when x is negative 3, what will be our y? So here we've replaced with negative 3 squared, we have negative 3 and the constant 7 there. So in this case, we continue. Negative 3 squared, it's 9. 9 times 2, we'll get our 18. 12 multiplied by negative 3, we're going to get negative 36. And then we have our minus 7 there. When you plug in this in your calculator, you're going to get negative 25. So when x rather is negative 3, the value of y is negative 25. So this is our coordinate box that we're going to use. When x is that one, when x is 0.54 or negative 6.54, our value of y is 0. And when y is negative 25, our value of x is 3. So we just need to go ahead and use the x or y plane to plot those points that we have identified there. So the points that we have are shown here. So when we have our x as negative 6.54, our value of y is 0. So this is our point there. And then when we have our value of x as 0.54, our value of y is 0 again. And then when we have x as negative 3, our value of y is 25. So it's just down here. Then at this point we just need to join the points using freehand, of course. So this is how a graph is going to be seen. So it's going to come out as a smiley face, but of course the down part here is supposed to be a 25. Now this is what we have up to here, of course the 25. So this is how our graph is going to be seen. Now notice when you're plotting, you don't need to go according to scale, but it has to be a sketch that makes sense. So you need to make sure that the coordinates are plotted accordingly. And that will be the end of our question there. Now we move on to the B part of the question, which says we differentiate. The first part is differentiate f of x is equal to 4x squared minus 3x plus 2 from the first principle. So this is the value that the function rather that we are supposed to differentiate using the first principle. Now when we are using the first principle, all we have to do is to use a formula. We're going to use a formula. So the formula is f prime is equal to the limit over h as it approaches 0, f open brackets x plus h minus f of x over h as shown here, right? So at this point, all you have to do is to plug in according to the formula, okay? According to the formula. So now you see here where we have our 4x squared. So this is our 4. Where there's x, we're going to plug in x plus h. So this is x plus h squared. And then here we know we have another x, so we're going to plug in negative 3. Of course it's already there. And then the x, it's we plug in x plus h as I said earlier on. And then this is my plus 2. Then this is the minus from the formula. This is the minus the original function minus the original function. So minus the original function, which is 4x squared minus 3x plus 2, divided everything by our h there. Okay, so we continue, right? So at this point we know to say when we have a power, we need to begin with a power there. So we know to say when we have x plus h squared, it means it is x multiplied by everything that is in the bracket, and h multiplied by everything in the brackets when we expand it. So this is my 4, I've just expanded it. This is x multiplied by everything that was in the brackets, and h multiplied by everything that was in the brackets. And then this is 3 multiply x, it is going to give us negative 3x. Negative 3 multiplied by positive h, it's going to give us negative 3h. And then this is my 2. Expanding this one, it's negative and positive 4x squared, it will be negative 4x squared. Negative and negative there, of course I'm going to get positive 3x, and then negative and positive, I've gotten negative 2. So over everything by h. So we continue with our calculation. We're just expanding anyways. So here we say of course this should not remain. We have our f prime of limit as h approaches 0. So we continue whilst we're expanding inside. It's x plus x rather, it's x squared, and then x times h, it's xh. The same here, h times x, it's xh, and h times h, it's h squared. So this part is already calculated, so I've just repeated it the same way that we did on top here. Right, so I'm only concentrating in the brackets there. So I have 4 multiplied by, now I'm going to expand the 4 multiplied by everything that is in the bracket. So 4 multiplied by x squared, it's 4x squared. 4 multiplied by xh, these are 2, so it's 2xh multiplied by 4, I've gotten 8xh. And then 4 multiplied by h, I've gotten 4h squared. And then this is just a repetition of what is on top here. Right, so at this point, notice what will happen. Notice, so we have common values. So here, this is a positive 4 minus 4x squared. Positive 4x squared minus 4x squared, these will go. Okay, and then what else is common? We have our minus 3 plus 3x, so these will also go. Right, and then we have our negative 2 here and the positive 2 here. These will also go. So what will remain is what we have here. What will remain is what we have here. We've remained with 8xh, and then we've remained with 4h squared, and we've remained with negative 3h. Of course, everything divided by h there. Right, so at this point our work becomes easy because we're just going to factor out what is common out of everything that we have here. Of course, it's h. When we get our h outside there, here we'll remain with 8x, and then here we'll remain with 4h, and then here we'll remain with 3. So the h will cancel now. Having cancelled the h, we'll have something that would look like this down here. So we'll have our 8x and then our 4h. Right, so now notice why where there was h I've put a 0. It's because h was now approaching 0. So where there's h, we're putting 0 there. So that's why I did not repeat the limit there. So we have our 0 there, and then minus 3. So what will remain, it's 8x. Of course, 0 multiplied 4, it's 0, so I've forgotten about it. And then I'll remain with 3 there. So basically, this is our answer based on the first principle. Now we move on. We move on to the next part of the question. The next part of the question there wants us to, to differentiate once again. Y is equal to 2x power 4 minus 1 over x minus 7x plus 9 with respect to x. Now, these are simple questions. All you have to do is to just rewrite it in standard form so that it won't give you any problems. So when we are trying to find y prime, we are going to write, this is already in standard form. It's not in a fraction, that's what I mean. So if it's in a fraction, it becomes a little bit tedious. So all we are going to do is to bring our x to the top. So when we bring it to the top, it means the power is going to change into a negative. So we have our negative 1 there. Then this is negative 7x, and this is already in standard form as 9. So what was the problem here in the whole equation was this one, which was a fraction, was just supposed to write it in standard form. Right, so in this case, all we are going to do is differentiate, of course, according to the power rule. So the power rule simply states that we're going to multiply the power multiplied by the number that is in front, the coefficient, so which is giving us 8, and then we subtract the power. It reduces by a 1, by a value of 1, so by a degree of 1. So from 4, if we remove 1, we're going to get 3, so that's x power 3 there. The same here, it's the power multiplied by the coefficient, so it's negative negative, it gave us a positive, and then the power should reduce by a degree of 1, so negative 1 minus 1, it's just going to give us negative 2. So this is the negative 2 that you're seeing there as a power. And then since here the power is 1, so we're going to say 1 multiplied by 7, it's just going to give us 7. It won't change anything. And then 1 minus 1, it's a 0. Any number raised to power 0, it's 1. So this x disappears because of that fact. And then this one disappears because it's a constant, since it's x power 0, and then 0 multiplied by 9 will give us a 0. That's why we forget about this part here. Right, so basically this is what you do. This is what you do, but it all depends if at all you want to take it back to its original state. So now how do we take it back to its original state? Of course, the law of indices will state that if at all you have a negative power, you take it at the bottom, it becomes a positive. So this is what I've done. So this equation, its statement is rather, it's going to be 1 over x squared, of course power 2 in this case, because it has changed into a positive now. And then minus 7. Basically, this is what you do. It is as simple as that. So, ladies and gentlemen, we are done with the first part of the question. We move on to the next part of the question. Please enjoy.